Let's talk about the implementation part right now. So we'll see two important things under this implementation. One, the components under the APIs. What components are there? What is the purpose of each of the API or the microservice? And then we'll just go to the code level overview, probably a kind of a pseudo code, and explain you how it works. So first, I'll take you to the components. So these are the major components which will be a part of the rate limiting service, the entire workflow. So one is the rate limiting service, which is basically the decision maker. So I'm calling this as a decision engine. So a request which comes from ELB lands on this particular microservice first. This will be the central service, collaborates with all other services. This is the one where the entire computation takes place, the creation of hash tables, take computing the timestamps, counter increment, all these logics, what we have discussed with respect to sliding window algorithm, that is written or drafted in this particular microservice, or so hence I raise up core of this entire project. So the next is a rule service, basically to do all the CRUD operations on the rules, create, update, edit, delete. So whatever you want to do and store, primarily, as I told you, we store first in the cache and then we store in the DB. So we use this service to update and create new rules. I have a endpoint, I have a new endpoint. If I want to set some new rule, I use this rule service to do all the CRUD operations. The rules DB, as I told you, to store the rules. So we'll have primarily two. One is cache layer, which is Redis. The other one is a Mongo probably, which will from cache we have a job which runs in the background and sync these rules to the DB at a particular intervals of the time. And we also have a throttling service, background job, which keeps a sync, which is what I told you, which keeps in a sync to between these DBs. So that's how these components work with each other. So these are the major components in this project. These are the top level API design. I'm just moving on. So first one is the generate key. This method or the service basically is used to generate a key, unique key for every request. So if it is authenticated, then fine, we can use it as a user ID. But if it is not authenticated, so this method will generate one unique key for every request. Whenever a request comes from the same place or same IP, or we'll have the same key as an output. So first method is the key generation. Once the key is generated, this goes to the allow request function. The allow request function takes the key as an input and decides whether to allow this particular request or not. So that is how it takes. Now, to do this internally, what happens is allow request calls another service called get info for key, which will get the status of this key. The entire logic which we do, this method calls the status of the key. So under this function or service, we will have the timestamps, which will compute the current timestamp, and it will fetch the data from the Redis and see what is the previous timestamp for this particular key. So the logic works in the points which I mentioned. If the key is not present the first time it is coming, it just inserts into the hash table with a counter set to 1. And if there is already existing, if the key already exists, and then if assume the current timestamp, if it exists, there will be a timestamp. So what we'll do, we'll fetch the timestamp from the DB, take the current timestamp of the request, understand the difference. If it is within the 1 minute window and the counter is less than our config value, then we will allow this request. If assume the counter value is more than the allowed value from the config, then we will just reject the request, and we'll wait till the window moves to the next 1 minute window. So this is how the entire flow works. These are the main key services we have in this app. So I'll probably walk through to one sample pseudocode kind of a stuff, which I'll share here, which is a collab interface. So I'm just most probably discussing here only on the decision engine. So allow request is my service which has been used here. This input is request key. So this returns either true or false based on the request. That is the output which is expected from this allow request API. And the request key can be a user ID or a unique key, which can be designed for the anonymous users. So for anonymous users, we can take the timestamp versus the IP. You can do a hashing of these things and get a unique key. Now, this is how the method calls. First, we'll have a config. So from the rule service, we update our default config, default rules for a particular endpoint, right? So we will fetch that and get what is the allowed number of requests for a particular endpoint and what is the window time. for 1 minute, for 5 minutes, for 1 hour, we have 500 requests allowed. So whatever is being configured. So we'll first get that particular from the configs, and then we will get the current time in the seconds from the by using the time function. And then what we'll try to do is get the time difference, that's the start time we call. If it is within the 1 minute accepted window, we'll just check that using this method called get current window, where we pass the request key and the start time. So this window will return few things within the window. If the request is there within the window, within the threshold or not. If that is there, it will return saying, hey, it will have a value called number of requests, which is if it is greater than the capacity. We say it's only 500 requests allowed. And if suppose the request is some 501, which is greater, the window that request is greater, then we return false. If suppose it is less, then we call a function called register request, which actually updates the counter value, stores the value back to the hash table, and then returns a true value. So this is a simple pseudocode which works for this algorithm.